Lesson 2, Resistors in Series, Parallel. Section 2.1. Series Resistance. This is a circuit with a DC voltage source and two resistors connected in series. The voltage is V and the resistors are R1 and R2. The current flowing through R1 and R2 is I. The voltages across the resistors R1 and R2 are denoted by V1 and V2 respectively. According to Ohm's law, V1 equals R1I, and V2 equals R2I. Kirchhoff's voltage law tells us that V equals V1 plus V2. V1 and V2 are substituted with R1I and R2I. The common factor I is factored out. Then V over I equals R1 plus R2. This equation tells us that we can simplify the circuit by replacing R1 and R2 with a single equivalent resistor Req. A circuit that has the same current I, when the same voltage V is applied, is called equivalent circuit. The equivalent resistance Req equals R1 plus R2. Experiment 2.1. Construct these circuits. The top circuit has two resistors in series, and the bottom circuit has one resistor. Set the DC source voltages V1 equals V2 equals 5 volts. Measure the voltages V1 and V2 and the currents I1 and I2. Confirm that V1 over I1 equals V2 over I2. The results of experiment 2.1. These were the readings on a multimeter. V1 over I1 was 20.1 kilo ohms, and V2 over I2 was 20.0 kilo ohms. They were almost equal. Note that the resistance values in the circuit diagrams are nominal. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.